Arithmetic sequence, it's the sequence which each term after the first one is increasing or decreasing by a constant value. And this constant value, we called it a common difference. This constant value, we called it a common difference. For example, write the first 6 terms of the sequence, and it's defined by an arithmetic sequence. Its first term is 100, and each time I am subtracting 30. So if the first term is 100 and I'm subtracting 30 every time, the second term is going to be 70. Then subtract 30, it's going to be 40. Subtract 30, it's going to be 10. Subtract 30, negative 20. Subtract 30 is negative 5. So we can notice here that the first term, we called it A1, and it's equal to 100. And the number that we subtracted every time is negative 30. Another example, if I have a matrix and this matrix is 4, 7, 10, 13, and so on, how do I know that it's an arithmetic sequence? If you are adding the same number every time or subtracting the same number every time, it's an arithmetic sequence. So as we notice, from 4 to 7, I add 3, and from 7 to 10, I add 3, from 10 to 13, I add 3. So every time I added 3, so the common difference here is positive 3, and the first term is equal to 4. Regarding exercise 10.1, and the first exercise is to write the first 6 terms of the given sequence. Number 1, the first term is 200 and the common difference is 20. It means that the first term is 200 and every time I'm going to add 20. So 220, 240, 260, 280, and 300. So here is the first 6 terms. Number 2, the first term is negative 7 and every time I'm adding 4. So negative 7, add 4 is negative 3, add 4 is 1, add 4 is 5, add 4 is 9, add 4 is 13. Regarding number 5, this was number 3, second one we solved it. The first term is 300, but each time I'm subtracting 90. So the second term is 210, then 120, then 30, then negative 60, then negative 150. Number 7, first term is 5 over 2, and every time I'm subtracting half. So it's going to be 4 over 2, which can be written as 2, then subtract half, 3 over 2, subtract half is 1, subtract half is half, subtract half it's negative 0, and then negative half, and so on. Regarding number 9, N is the general rule, and as we can see, it's adding 6 to the previous term. So the common difference here is adding 6. So negative 9 after adding 6 is negative 3, after adding 6 is 3, after adding 6 is 9, 15, and 21. General term of an arithmetic sequence, and how we can define a general term or a general rule to find the term in an arithmetic sequence. The general term is equal the first term plus n, number of the term, minus 1 multiply d, and d is the common difference. Example, using the formula for the general term of an arithmetic sequence, find the 9th term of the arithmetic sequence whose first term is equal to 6. So A1 is equal to 6, and the common difference is equal to negative 5. So I wanted to find the ninth term, and the ninth term is A9. So AN, the general rule, is A1 plus N minus 1 multiplied by D. So A9 is equal A1 plus 9 minus 1 multiplied by negative 5. So it's 6 plus 8 multiplied by negative 5, which is equal 6 minus 40, so it's equal to negative 34. Find the indicated term of the arithmetic sequence of the first term and the common difference are given. Regarding question number 15, I have the first term 13 and the common difference is 4, and I wanted to find A6. To give you a quick method, A6 is A1 plus 5D, because n minus 1 is 6 minus 1, which is equal to 5. So A1 is 13 plus 5 times 4, which is 20. So the answer is 33. Regarding question number 16, find A16. So it's equal to A1 plus 15D. So it's equal to 9 plus 15 multiplied by 2. By using your calculator, it's 39. Question number 17, I want to find A50, and the first term is 7 plus 49 multiply the common difference, and the common difference is 5. So 5 multiply 49 plus 7 is 252. Number 18, find A60, and A60 is A1 plus 59 multiply D. So it's 8 plus 59 multiplied by 6, and the answer is, by using your calculator, is 362. The formula for the general term, and the general term, not to forget that AN is equal A1 plus N minus 1 multiplied by D. So I wanted to write a general form for number 23, and also I wanted to find the 20th term. So A1 is equal to 1, and the common difference, the number that I'm adding every time, is 5 minus 1 or 9 minus 5, so the common difference is equal to 4. So the general term AN is equal 1 plus N minus 1 multiplied by 4. If you wanted to simplify it, you can multiply 4 by N and 4 by 1. So 1 plus 4N minus 4, so it's equal to 4N minus 3. So this is the general term of this sequence. So I want to find A20. So A20 is 4 by 20 minus 3, which is equal to 77. Regarding question number 27, AN is equal A1 plus N minus 1 multiplied by the common difference, which is equal to 2. So AN is equal 9 plus 2N minus 2. So AN is equal to 7 plus 2N after I expand the 2 by negative 1. So what if I want to find A20? It's 7 plus 2 by 20, so it's equal to 47. The sum of first n terms of an arithmetic sequence. I'm using this rule. Sn is equal n divided by 2 multiply the first term and the last term to find the sum of some values or a specific number of values in an arithmetic sequence. Find the sum of the first 15 terms. We know that the Sn rules is n over 2 a1 plus an. So I wanted to find the sum of the first 15 terms. So it's 15 divided by 2 a1 plus a15. So the first step, you gotta find what is a1, what is the number that you are adding or subtracting every time, and you can find it easily by subtracting 3 minus 6. So the common difference is 3. So first I need to find a15, and the a15 is a1 plus 14d. So a15 is 3 plus 14 multiplied by 3, and this is equal to 45. So S15 is 15 divided by 2 a1, and a1 is 3 plus 45. So it's 15 divided by 2 multiplied by 48. So half the 48 is 24. So it's 15 multiplied by 24. And 15 multiplied 24 by using my calculator is equal to 360. So the sum of the first 15 terms is equal to 360. Another example from the exercise 10.2, find the sum of the first 20 terms. So the first term, a1, is equal to 4. The common difference, the number that you are adding every time, is positive 6. So I wanted to find a20, and the a20 is a1 plus 19 multiplied by d. So a20 is 4 plus 19 multiplied by 6. 180. Now I wanted to find the sum of the first 20 terms. So it's 20 divided by 2, and a1 is equal to 4, and a20 is 180. So 20 over 2 is 10 multiplied by 122, so it's 1220. Find the sum from 1 to 100 for the first 100 consecutive terms. So a1 is equal to 1, and as we can see clearly that the first 100 consecutive terms, they form an arithmetic sequence. So the common difference, the number that you are adding every time, is 1. So I wanted to find the sum of the first 100 terms. We know that Sn is equal n over 2 and a1 plus an. So S100 here is equal 100 over 2, and the a1 is 1, and an is equal to 100 as it's the term number 100. So it's equal to 50 multiply 101, and 50 multiply 101 is equal to 50. 5050. This is the sum of the first 100 terms. Find the following sum, and as we know, this sign is called sigma, and it's for summation. Sigma for summation. So I wanted to find the sum of the first 25 terms. How I figure out from term number 1 to the term number 25. So I wanted to find the sum of the first 25 terms. Where is the sequence? The sequence is 5i minus 1. And to figure out the sequence, I'm going to replace I with 1. So if I wanted to find a1, it's 5 multiply 1 minus 9, which is equal to negative 4. If I wanted to find a2, it's 5 multiplied by 2 minus 9, which is equal to 1. If I wanted to find a3, it's 5 multiplied by 3 minus 9, which is equal to 6. So as we notice, every time I'm adding 5. So the first term is negative 4, and the common difference is equal to 5. To find the sum and it's represent an arithmetic sequence. To find the sum, it's n over 2 a1 plus an. So I need to find the 25th term, and the 25th term, it's 5 multiplied by 25 minus 9, as I plug I here with 25. So 5 multiplied 25 minus 9 is equal to 116. So Sn is S of 25 is 25 over 2. The first term is negative 4 and the last term is 116. So 25 divided by 2 multiply negative 4 plus 116. This is equal to 1400. Find the sum of the given summation. Sum of the first 30 terms, since I here is equal 1. So I need to find the first term, and the first term is 6 times 1 minus 11, which is equal to negative 5. And if I want to find the second term, 6 multiplied by 2 minus 11, which is equal to 1. Third term, 6 multiplied by 3 minus 11, which is equal to 7. So it's clear for me that 5, negative 5, 1, and 7, and so on. So it's an arithmetic sequence where the first term is negative 5 and the common difference is equal to 6. So what if I wanted to find the sum of the first 30 terms? I'm going to follow the rule Sn is equal n over 2 a1 plus an. So here an is S30, 30 over 2 a1 plus a30. So I go back to the rule and I wanted to find a30, which is 6 times 30 minus 11, which is 180, minus 11, 169. So S30 is 30 over 2 and a1 is equal to negative 5 and a30 is positive 169. So the sum is 15 multiplied negative 5 plus 169 equal to 2460.